Good morning. So today we're going to tackle about the Pythagorean theorem. So first, what is Pythagorean theorem? In mathematics, the Pythagorean theorem or Pythagoras theorem is a fundamental relation in Euclidean geometry among the three sides of a right triangle. It states that the area of the square whose side is hypotenuse, which the side opposite the right angle, is equal to the sum of the areas of the squares on the other two sides. So in simple term, Pythagorean theorem is the square of the length of the hypotenuse of a right triangle equals to the sum of the squares of the lengths of the other two sides. So next is the Pythagorean equation. This theorem can be written as an equation relating the lengths of the side A, B, and C, often called as the Pythagorean equation. So, in Pythagorean equation, where C represents the length of the hypotenuse and A and B is the length of the triangle's other two sides. So, there are other forms of the Pythagorean theorem. If C denotes the length of the hypotenuse and A and B denote the length of the other two sides, the Pythagorean theorem can be expressed as the Pythagorean equation, which is the A squared plus B squared equals C squared. So, next is if the lengths of the both A and B are known, then C can be calculated as C equals square root of A squared plus B squared. There are also a forms of Pythagorean, which is if the length of the hypotenuse C and of one side A or B are known, then the length of the other side can be calculated as A equals the square root of C squared minus B squared. There are also a form of Pythagorean theorem which can be expressed as B equals square root of C squared minus A squared. Here is an example of finding or looking for length of the hypotenuse using the formula a squared plus b squared equals c squared. So there is a given value of the both side, which is the a and b. A is equal to 15 and b is equal to 20. So we are going to find the x, which is the length of the hypotenuse. So A is a value of 15, so 15 squared. Then B is equal to 20, then 20 squared. 15 squared plus 20 squared equals C squared. 15 squared is equal to 225 plus 20 squared is equal to 400 equals C squared. So 225 plus 400 equals 625 equals C squared. We're going to square root the 625, which is it equals to 25. So the value of length of hypotenuse is 25.
History of Pythagorean Theorem. The Pythagorean theorem was first known in ancient Babylon and Egypt beginning about 1900 before Christ. The relationship was shown on a 4,000-year-old Babylonian tablet now known as Plimpton 322. However, the relationship was not widely publicized until Pythagoras stated it explicitly. Pythagoras lived during the 16th century before Christ on the island of Samos in the Aegean Sea. He also lived in Egypt, Babylon, and southern Italy. Pythagoras was a teacher and a philosopher. Pythagoras found out that for a right-angled triangle, with one of the angles being 90 degrees, the square of the hypotenuse is equal to the sum of the squares of the other two sides. A squared plus b squared is equals to c squared. In other words, the green square's area with area c squared equals the sum of the two others. It is exactly the yellow square's area a squared plus the blue square's b squared. Euclid's elements. The Elements is a mathematical treatise consisting of 13 books attributed to the ancient Greek mathematician Euclid in Alexandria, Ptolemaic, Egypt on 300 before Christ. It is a collection of definitions, postulates, propositions, theorems and constructions, and mathematical proofs of the propositions. The books cover plain and solid Euclidean geometry, elementary number theory, and incommensurable lines. Elements is the oldest extant large-scale deductive treatment of mathematics. It has proven instrumental in the development of logic and modern science, and its logical rigor was not surpassed until the 19th century.
I'm going to discuss the Euclid's element, description of the three classical problem of antiquity. In Euclid's book of elements, there are hundreds of constructed problems solved by Euclid using his own methods and written in that book. But there are also problems that cannot be solved using his own method. He cannot solve those geometric problems using only the compass and the straight unmarked straight edge because that is his tools to solve those geometric problems. These problems are namely doubling the cube, angle trisection, and squaring a circle. And these three problems is known in the ancient Greece as Greek classical problem or the classical problem of antiquity. Doubling the cube. Given a cube of side A, a cube with double its volume can be constructed if two mean proportional, x and y, can be determined such that a is to x equals x is to y equals y is to 2a. And this situation was being formulated by Hippocrates of Chios. But with his idea, Euclidean developed his own idea in constructing the doubling the cube. Here is the Euclidean rule for constructing the doubling the cube. First, draw 2 points named point A and B. Next, draw a circle, its center on point A extending to point B. Then he draws another circle, centered at point B, extending to point A. Then, the next one, he marked one intersection between the two circles and named it point C. Then, he drew line segments connecting points A, B, and C. With this illustration, he created an equilateral triangle which has the same sides and the same value of angles. Next problem is angle trisection. Angle trisection is a classical problem of straight edge and compass construction of ancient Greek mathematics. It concerns constructions of an angle equal to 2/1/3 of a given arbitrary angle using only two tools, an unmarked straight edge and a compass. The next problem is squaring a circle. Squaring a circle is a problem proposed by ancient geometers. It is the challenge of constructing a square with the same area as a given circle by using only a finite number of steps with compass and straight edge. The difficulty of the problem raised the question of whether specified axioms of Euclidean geometry concerning the existence of lines and circles implied the existence of such a square. You would understand these old problems by viewing the YouTube link that I would send in the GC. Thank you.